Perfect. Okay, so to go back over this, we're going to go over the exponent rules today. And for our very first example here, basically what's going to happen is we are going to go 3 to the power of 2 times 3 to the power of 2. Well, each of those 3 to the power of 2s are 9. And then 9 times 9 is 81. For the next one, 2 to the power of 3 is 8. 2 to the power of 4 is 16. 8 times 16 gives us 128. And then 10 to the power of 3 is 10 times 10 times 10, which is 1,000 times 10. So 1,000 times 10 is 10,000. The only difference you're going to do with the second part is notice in between you're dividing, you're dividing, you're dividing, you're dividing. So we still figure out each of the powers, but then we divide like we did right here. So 3 to the power of 4 divided by 3 to the power of 2. Well, 3 to the power of 4 is 81, and 3 to the power of 2 is 9. So 81 divided by 9 ends up being 9. 10 to the power of 5, that's a real big number. It ends up being 100,000. And 10 to the power of 3 is 1,000. We divide. I end up 100,000 divided by 1,000 is 100. 3 to the power of 4 divided by 3. Well, 3 to the power of 4 is 81. Divided by 3, we don't have to figure out that power. It's already done for us. And 81 divided by 3 is 27. Is everybody okay there? The last one, look what happens. Inside the bracket, you've got a power to figure out. And then you take your answer and you raise it to another power. So take a look. 2 to the power of 3 is 8. That's where I got that 8. But now 8 being raised to that power of 2 on the outside. So 8 to the power of 2 is 64. So 3 to the power of 2 is 9. And 9 to the power of 4, 6,561. Next one, 10 to the power of 2 is 100. 10 times 10. And 100 squared is 100 times 100, or 10,000. And this is a cool one here because 1 to the power of 5 is 1 times 1 times 1 times 1 times 1, which is 1. And then we take 1 and raise it to the power of 3, which is 1 times 1 times 1, which is 1. And we've got the first 3 columns done in that table. Is everybody okay with that? Give me a hand in the air if you've got that left side of those 3 columns all done.
Sir, I don't know which page this is. Is this a page or I'm
This
not?
is the very next page in line after you did the homework. So the one we just did, Connor, where we did the operations with fractions and stuff like this, it should be the very next page. It's a sideways page. The holes are at the top. It's called exponent laws.
I think my thing's mixed up. Okay, I'll try and find it real quick.
Okay, it should be the next one in line, Connor. It should be the one right after the last page that we did.
Yeah, my pile's mixed up just a bit. But
okay.
I believe it's like near the top, so I'll find it.
Okay, perfect. Is everybody okay with that now? So we have our first 3 columns done. Now, we're going to solve the last 3 columns there over on the other side. We're going to do this a little different. This is called using the power laws. So watch how this works. You're given 4 questions right here. And the instructions say, keep the base and add the powers, add the exponents. So take a look at your first question. 2 to the power of 2 times 2 to the power of 3. Notice the bases are the same. So the person kept the base, which is 2, but they added these 2 powers, 2 and 3. You ended up with 2 to the power of 5. Now simplify 2 to the power of 5 in your calculator, and 2 to the power of 5 is 32. Okay? Everybody good there? So what would the next one be? 3 to the power of 2 times 3 to the power of 2. What should I put right here?
3 to the power of 4?
Exactly. We add the powers together and we keep the base. And in our calculators, 3 to the power of 4 ends up being 3 times 3 times 3 times 3. I believe it's 81. What should my next one be? Somebody new. If you've already answered, don't answer again. 2 to the power of 3. 2 to the power of 7. Add the powers together. 2 to the power 7, and 2 to the power 7, you just multiply 2 by itself 7 times. I think it's 128. What about this next one?
10 to the power of 3.
That's what I said too. You know that? I'm a math teacher, and that's what I said too, but it's actually not correct. Does anybody know what the correct one is here? I got
10 to
this
the
one.
power of 4.
How did you get 4?
Well, because there's an extra 10 there and it doesn't have an exponent, so I just added that on.
When you see a number like 10 right here, and there's no power, it's not a power of 0, it's actually a hidden power of 1. 10 is the precise way of writing 10 to the power of 1. So don't forget that there's a 1 there. So when we go and add these together, we actually get 10 to the power of 4. So good for you. I made that same mistake when I first did this. Very easy to do. And 10 to the power of 4 in your calculator, I believe, is 10,000. Is everybody good? First part done? Did you find it, Connor?
Yeah.
Okay, good. Now we go to the next one. This says keep the base, but subtract the exponents. So when we're dividing here in between, we don't add them together, we subtract. You see how we go 5 take away 2 is 2 to the power of 3, and then we get 8? So what would our next one be? Somebody new who hasn't answered yet. 3 to the power of 4 divided by 3 to the power of 2?
3 to the 2.
There it is. And 3 to the power of 2 is 9. What about the next one? What should we get for this one?
10 to the power of 2.
We subtract 5 and 3, we get new exponent of 2, just that one exponent, and we get 10 to the power of 2 is 100. What about the next one?
3 to the power of 3.
Good for you. What's hidden on that 1, 3 that we just learned about? What's hidden on this 3? There's a 1. So when we subtract, we have to take away 1 from 4. We get 3 to the power of 3, or 27. All right, we're almost done. Last one here. This says keep the base. Well, we have to because there's only one base. Do you see how there's 2 exponents, but only the 1 base? So keep it. And it looks like we multiply the exponents here. So the first one, 3 times 2 is 6, and then 2 to the power of 6 is 64. What about the next one? What's our simplified form going to be?
3 to the power of 8.
There it is. And 3 to the power of 8 is 6,561 when you enter that in your calculator. Next one is 10 to the power of?
4.
4. There it is. 10 to the power of 4 is 10,000. And the very last one, 1 to the power of 5 raised to the power of 3 is 1 to the power of 15. 1 times 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 1 is 1. Doesn't really matter how many times you multiply it by itself, right? So here's what I want you to do. You guys just filled out your table, okay? All those columns. I want you to take a look at the very top to the column headings. There are 2 headings that say example. Look down both columns that say example. And what do you notice when you look at both of those columns?
They're all the same numbers?
That's exactly it, Manfred. They are the exact same. So for example, if I scroll up here, do you see this very first question here on the one side under example is 2 to the power of 2 times 2 to the power of 3? It was the exact same question as on the other side under example, 2 to the power of 2 times 2 to the power of 3. This whole column down here, example, is the exact same as down here. Make sense? Now, there's another column at the top that has the same heading. It's called evaluate. Take a look at the numbers going down evaluate. What do you notice?
They're the same numbers.
They are the exact same also. So if you take a look here, all the numbers under this evaluate, 32, 81, 128, 10,000. 32, 81, 128, 10,000. 8, 9, 127, 64, 6,561, 10,001. They're all the same. So let me just step back. Everybody clear your mind for a second and just hear me out here. What we did was we did the exact same question 2 different ways. The very first way is the old school way. This is the grade school way. Oh, you want me to figure out 2 to the power of 2 times 2 to the power of 3? 2 to the power of 2 is 4, 2 to the power of 3 is 8, and 4 times 8 is 32. That's so grade school. Now we have a new way to do this to get the exact same answer. We say, oh, look, the bases are the same. All I have to do is add the powers together, and I get 2 to the power of 5. 2 to the power of 5 is 32. If you think about this, just watch this for a second. 2 to the power of 2 times 2 to the power of 3. 2 to the power of 2 is 2 times 2. And 2 to the power of 3 is 2 times 2 times 2. But do you see what we're doing in between 2 to the power of 3 and 2 to the power of 2? Do you see how we're multiplying? Well, then in between here, I've got to multiply the 2, and I get this. And when you look at it, isn't that just 2 times 2 times 2 times 2 times 2, 5 times? Or 2 to the power of 5? It's an easy way to get a single power before we evaluate. This is called the multiplication law. Okay, so let's go to the next page. I am going to come back to this page, but let's go to the next page. And notice we have exponent rule. Everybody should see this handout, and I'm going to talk about the multiplication rule. The multiplication rule says this: when you multiply powers of the same base, you guys stay on that page. Multiply powers of the same base, multiply powers of the same base, multiply powers of the same base, multiply powers of the same base. All of these have the same base. What we do is we keep the base. Keep the same base. And then what did we do to our powers? What did we do to our, what did we do here in the blue? What did we do to these powers, these powers, these powers, these powers? What did we do to them?
Added them.
We added them together right here. So when I go over to here, we keep the same base and we add the exponents. So as an example, over here, let's pick a number like 7 and we'll raise this to the power of, I don't know, let's go, and I'm gonna use my equation editor, okay, if that's okay. I'm just gonna make it look a little more neat. So I'm gonna open up an equation. There it is. And here's what we can do. Let's pick a base. I just picked 7. Eventually we'll open up here. So I picked 7 and I raise this to the power of, I don't know, let's go 6. And then what we're going to do is we're going to say times. We'll do multiply. And actually, I want to get in the habit of using this dot. Okay, instead of a multiplication sign, I'm going to use this dot here. This is the same as this. So that multiplication and that dot are the same, but I want us to get in the habit of showing multiplication with a dot instead of multiplying because I don't want it to mix up with another variable, okay, like a variable. So we have to have the same value. We have to have the same base, but let's raise it to the power of, let's go 2. And what we're saying is that this is actually equal to 7 to the power of, and we add them, 6 plus 2, which is actually equal to 7 to the power of 8. Does that make sense to you guys?
Yeah.
So this right here, I'm going to shrink down a little bit and I'm going to put as our example right here. Okay. But this is just one specific example. What I'm going to do over here is something a little more complicated. but it's going to generalize it. Instead of me picking 7 or 6 or 5 as a base, I'm going to pick a base and I'm going to call it A. A can be any number, and in my case, I picked A to be 7. I'm then going to raise A to a power, and instead of it just being a 6, I'm going to pick a variable and I'm going to call it M. Is everybody okay with A in this case is the 7, and M in this case is the 6? We then multiply it by, and maybe I shouldn't have used that multiplication symbol, but then do you see how we have to have the same base? So if my base is A here, it's got to be an A over here. But our exponents don't have to be the same, just the bases. So I can't put an M here because I don't want our exponents to be the same, so I put an N. And what I said is if you have some base to a power times that same base to a different power, keep the base and add the powers. And do you see how this is the general form of this over here? Is everybody good with that? Everybody can put their hand down now too. You don't need your hand in the air, okay? So you can take your hand down. Perfect. Is everybody okay there? All right, let's go to the next one. Over here, when we went to that chart, when we went to the green down here, do you see the only difference we did was we divided? So watch what happens here. Just like we did the red up here, I'm going to do this example. 2 to the power of 5 divided by 2 to the power of 2. So if I have up top 2 to the power of 5, which is actually exactly that. 2 to the power of 5 is this. Perfect. So here's 2 to the power of 5. And now we divide it by, I'm going to put a division, 2 to the power of 2. So I'm going to clone this, but I'm going to get rid of 3 of them. And do you see how this 2 to the power of 5 and 2 to the power of 2? Do you see how it's this 2 to the power of 5 divided by 2 to the power of 2? So when I do this, watch what happens. I look at the top and the bottom, I say, well, wait a second. This 2 and this 2 divide out. And this 2 and this 2 divide out. And take a look what I'm left with after I divide those out. How many 2's are up in the top? There's just 3 of them. So after I divide those out, it's easy to see in this example how 2 to the power of 5 divided by 2 to the power of 2 just leaves us with 2 to the power of 3. That's all we have up top. So our rule for this, when we have our division rule, is this. Keep the base, but instead of adding the powers, we subtract. Okay. So as an example, I can take this right here and I'm just going to clone it. I'm going to bring it right down here. I'm going to use these same numbers, but here's the difference. I can't multiply in between. What do I do instead? So if I take this equation, instead of multiplying in between, I'm now going to show division. So I can use this symbol right here, or I can use a division sign. It's the same either way. So I'm going to show division. I don't add my powers. I now subtract. And I don't end up with 8 as my power. I end up with 4. Did you see the difference there? I'm going to insert this into this example right here. So how does this right here, this general form, change down here? A to the power of m divided by a to the power of n is a to the power of m minus n. All right.
Sir,
Everybody, yes.
why are we subtracting the
The reason we're subtracting here is, do you see how it works here? with the division rule? Do you see when we had the green, when we're dividing in between, in order to get the correct power, we had to subtract the 2 to get 3. When we were multiplying in between, though, we had to add them. But when we're dividing in between, you've got to subtract. Do you see how all of these we subtracted to get this new power? Does that make sense, Ashton?
Oh, yeah, thank you.
Okay, so this is a second rule, not the multiplication rule where we add. This is the division rule where we subtract. Is everybody okay there? And lastly, take a look at the very last examples we did. The exponent rule. If I went 2 to the power of 3 raised to the power of 2, then to show that 2 to the power of 3 raised to the power of 2 is just 2 to the power of 3 times 2 to the power of 3. That's what happens when you square. And when you go 2 to the power of 3, let me just show you here. I'm going to open this up because I want you to understand this. In a long way, do you see 2 to the power of 3, and this whole thing is being squared? Well, what does it mean when we square something? When we square something, we just take 2 to the power of 3, and we multiply it by 2 to the power of 3. That's all 2 to the power of 3 squared is 2 to the power of 3 times 2 to the power of 3. Well, 2 to the power of 3 is just 2 times 2 times 2, and 2 to the power of 3 is just 2 times 2 times 2. There's 6 of them. Do you remember the multiplication rule where we add those together? It's just 2 to the power of 6. If I were to expand this out, I get 2 times 2 times 2 times 2 times 2 times 2, and there's 6 2's all being multiplied together. So I'm going to insert this equation, and I'm actually going to use this as our example. Cut. And I'm going to use this as our example right here. There's the example. What did we do to these powers? We multiplied them to get this 2 to the power of 6. We don't have to show this intermediate step. We can just go right from here to the very end, okay? So our general form here is you take a base A and raise it to the power of M. 2 to the power of 3, 2 is my A, 3 is my M. And then I raise it to some other power like an N. The N would be this power of 2 in this case. And all we have to do is just go A to the power of M times N. These are the 3 exponent rules that we are going to use both today in a little bit of work, and then to Monday in class, we're going to go a little bit farther. But I want to show you what you guys are going to finish with today. This is perfect timing. Is everybody okay with this page?
Yeah.
Can I copy off of it?
Yep. Again, this is in a video too, so if you ever get behind and you don't get something copied, I will be posting videos of our lessons, okay? You can go to Edsby, the link to the Teams meeting will disappear, but in the spot will be probably a couple videos. So I have a video of the 3.2 lesson that I'll post and a video of the 3.3 lesson right here, day 1. So just to review real quick, and I'll scroll back down, here are the 3 rules. When you have the same base and you've got 2 powers and you're multiplying in between, add the powers together. General rule right here. When you have 2 of the same base, but you're subtracting, or sorry, when you're dividing in between, you subtract the powers. 7 to the power of 4. Whatever 7 to the power of 6 divided by 7 to the power of 2 is, it's the exact same as what 7 to the power of 4 is. My last class, academic class, got a real kick out of this, and you're going to hear a lot of this. Do you see this right here? The green? This green is Mr. Bracken, right here. That's Mr. Bracken. And this yellow is Dave. I'm the exact same person. 7 to the power 6 divided by 7 to the power of 2 is Mr. Bracken. 7 to the power 4 is Dave. we're the exact same person. But this is easier to deal with than this. Here's Mr. Bracken again. 7 to the power 6 times 7 to the power 2. That's Mr. Bracken. But this is Dave. We're the same person. Those two are the same, the green and the yellow. But this is easier to deal with. And down here, this is Mr. Bracken right here. 2 exponents. Ooh, that's pretty complicated. Dave's a lot easier to deal with. 2 to the power 6. They're the same. Does that make sense to you? So just to prove that, if I grab my calculator, just watch here for a second. Bracket 2 to the exponent 3. End my bracket. Oh, let me delete that. Go across. End my bracket and raise it to the power of 2. Do you see the green right here I put in my calculator? My answer to that is 64. But instead, if I just went 2 to the power of 6, you see how I also get 64? These are the same, but this is easier. It's only got the 1 power. Up here, clear, 7 to the exponent 6, go across, divided by 7 to the power of 2 equals 2,401. Well, guess what? 7 to the power of 4, which is right here, is also 2,401. Do you see how they're the same? So we could do the top two. It'll work out to be the same, but here's what you guys are going to do for me, okay? The very next page looks like this. You are going to just complete this page for me, and only this page. Okay, you should have it in your notes. Mine looks a little different with some added features, but you should see at the top, practice exponent rules. What I'm going to do is I'm going to post a link in Edsby, and I do want you to take a picture of your work and upload it at some point this weekend, but it's got to be done by Monday. It's got to be done by Sunday night, okay? I would just think get it done today. But this is what's due by beginning of the class Monday. All right, is everybody okay with that? I'll post that in Edsby. Monday, I will see the majority of you because I think 2/3 of you are in cohort A and only 1/3 are in cohort B. So I'm going to see the majority of you Monday. You'll be able to get a textbook. Hopefully you guys can get a calculator this weekend. But if not, I can get you one. But please try to get one this weekend because I don't have enough for everybody. I'll get you the textbook. But cohort B, you're logging in at 8:15 to follow along on the message. All right. Follow along on the video, follow along on the lesson. So you are logged in at 8:15 Monday morning. I'll have a timer going for when we're going to start, and hopefully everybody's good with that. So before we call this a day and get you guys working and so on, is there any questions on anything here?
Sure.
Yep.
Do we do the front and back of the practice? exponent?
Nope, just the front side. Don't do the back side where it says exponent laws continued. Do not do the back side, just the front side, okay?
Okay.
Just the one page. Any other questions at all? Great question, Manveer. Thank you. Just the front side of that page. And if you don't mind, maybe what I'll do just to get you kind of going here, let's just take a look at this example here. Can you guys just watch? We'll do one together. It should be ready at noon. Awesome. Jules, yep. Don't worry about paying. I'll e-transfer her. It's good. Okay. Sorry about that. So when we take a look here, we'll just do this example. My next step, I would do this. Oh, I thought I had it here. You know what? Don't worry. We'll I'll let you go with it unless you want me to, unless you want to see it done. This would work out to be 7 to the power of 8. So we write it down here. Just so you see one of them done. Sorry about this. This would equal 7. I would do the exponent. And 4 plus 4 gives me 8. But then I have to still divide, and I would show this right here, this division. Might be easier to do it this way. Yeah, this will be easier. So this right here gives me 7 to the power of 8. So I write that out, divided by 7 to the power of 2. And then when I get 7 to the power of 8 divided by 7 to the power of 2, I would subtract, and I would end up with 7 to the power of 6. That's writing as a single power. So my next step, I'm going to try to write really neat here. My next step in solving this would be equals 7 to the power of 8 divided by 7 to the power of 2. I would then write this as 7 to the power of 8 take away 2 using my power laws is 6. I use the multiplication law here and then the division law right here, and I got 7 to the power 6. You just wrote it as a single power. This is your first mark. Then it says to use a calculator to evaluate. Then you would go and say 7 to the exponent 6 equals, and you would write this number underneath. 1, 1, 7, 6, 4, 9, I believe is what it is. Yep. That's how you would get your final answer. But you must write this single power first. Is everybody okay with that? This right here is just the basics. I'm going to take this up first thing Monday, and then we're going to move on to some more complicated examples. But this is due uploaded by Monday, okay? Any other questions? Anything else you want me to talk about or go over before I let you guys go for the day?
Yeah, I know you already went over like how to solve like D, like that type of equation there. Could you go over it again of how to solve that?
This one right here?
Yeah.
Yep. The only difference with this one is you've got a base raised to a power raised to another power. So what do we do to these two powers? It says on our previous page, and use this page.
That's a multiply, right?
It's a multiply, exactly.
Okay.
So when we go here, our first step is to keep the base. And when we multiply, we get 12 up top. And then we just keep 2 to the power 3. Now, what's the rule, Connor, when we multiply with like bases? So I'm going to go back here. When we multiply with like bases, what did we do to our powers?
To add.
Add them together. So what would be my final statement here? I keep the base and add these two. I get to the power of
5.
Sorry, the one's hidden there. So 15, right?
Oh,
I hidden on the 2. It's my fault. My 12 looks like a 2. So 12 plus 3 gives us 15. Now you take your calculator, go 2 to the power 15, and see what it equals right here. All right?
All right.
So is everybody good? So with that, hopefully today's lesson went good. You're just responsible for the front side. So when you get done, take a picture. I'll have a little link for you to submit in EDSB again. I'll put the deadline as Sunday night, but get it done today. Just get it done and get it submitted. You guys have an afternoon class at 1 o'clock with the class you had in the morning yesterday. And cohort A, I will see you Monday morning, bright and early. Cohort B, I will also hear you Monday morning, and you will hear me at 8:15. So make sure you're up and ready to log into a Teams meeting, which I will post. Okay. You guys are awesome. Have a great weekend. It's going to be a really, really good class. I think it's going to go well. At this point, if you are confident, you can log out and you are good to go.
Bye. Have a good weekend.
Yes, you too, Braden.
Bye, sir.
Yes, we'll see you soon. Sorry, I can't see everybody's names, but let's just say one big goodbye, and you guys are awesome. Stay good, enjoy the weekend, and I'll see you guys bright and early Monday morning, okay?
Bye, sir.
Keep following with EDSB there.
Sir.
Give me 1 sec, Ashton. I'm just going to shut down the recording, and then I will answer your question, okay? Just hang tight there, Ashton. Sorry about this.